All right, guys, there we got rational functions part 2. We're going to expand just a little bit on what we did yesterday. Hopefully no big deal. And here we go. All right, sketching graphs of rational functions. These are the steps you need to take. All right, every time you do one of these a day. Number 1, factor. Factor the numerator and denominator if you can. Number 2, find the intercepts. You find the x-intercepts by whatever makes the numerator 0, and the y-intercepts, you're going to plug in 0 for the x's. Okay, that sounds kind of weird, but that's how you find x-intercepts, y-intercepts. Vertical asymptotes, we did this yesterday. You find the vertical asymptotes by figuring out what makes the bottom of your denominator equals 0. Horizontal asymptotes, we're going to have the 3 rules we did yesterday. Remember, it's all about the degrees on your numerator and denominator. And then we're just going to sketch the graph. And I'll be honest, we're going to use our calculator to help us sketch those graphs. So I'm not so worried about the sketching as much as I am you finding those things right there. All right, graph this one is take the domain and range. All right, so to graph it, we need all kinds of info. So you basically need to find those 4 things every time you do one of these. Let's find the x-intercept first. The x-intercept, sorry about that, is whatever makes the numerator 0. So what we need to do first is factor the numerator and denominator. Okay, so I'm going to go ahead and do that right here. And I'm going to make it a little quick. I'm not going to show you the whole divide slide thing. I'm just going to factor it pretty quickly so the video won't last all day. You're welcome for that. And there's what I get when I factored. So the x-intercept is whatever makes your numerator 0. So there's 2 x-intercepts here. One of them is 1/2 and one is -4. That's where the graph is going to cross the x-axis. The y-intercept, all you do is you plug a 0 in for every x. So I'm going to go back up here to the top. I'll put a 0 in for all the x's. All that leaves is a -4 on the top and a -2 on the bottom, which is +2. So it's going to cross the y-axis at +2. The vertical asymptotes, whatever makes your denominator 0, so it'd be x equals -2 and also x equals 1. Got those from right there. And your horizontal, remember you have 3 rules for those. On this problem, the degrees are the same. They're both degree 2, so you do leading over leading, which is y equals 2. There's my horizontal asymptote. So to graph it, I should have taken a picture of a graph here. Matter of fact, hold on. And just like that, there's a graph there. It's amazing. Okay, so I'm going to put everything I know on this graph right here. So let's see what we got. What info do we have? I know the x-intercept is 1/2 and -4, so it's going to cross the x-axis at 1/2 right there, and also at -4 right there. It's going to cross the y-axis at 2, which is very close to the x-intercept. Okay, asymptotes. It's got a vertical asymptote at -2, which is right here. I'm trying to draw that. -2. Sorry about that. And 1, which is here. And it's got a horizontal asymptote at 2. So the horizontal asymptote is right here. Okay, which is weird because that's also where the x-intercept is, that's completely okay. Remember I told you yesterday, horizontal asymptote just tells you what the ends are doing of the graph. What are the ends of the graph doing? Okay, that's what the verticals do. So what we're going to do to graph this thing is we've got 2 options. We can use our table function on the calculator to see where the points are that we need, or we could, by the time you do table, you've already graphed it anyway. So I'm going to let you punch it in on your calculator to graph it. But you got to show me those. You got to show me those points and those asymptotes on your graph. Okay, I'm gonna punch it in real quick, and then we'll draw the graph. All right, and the graph's looking very much like this. It's going that way over there. In between the 2 verticals, it's doing this. Remember, it's got to hit those x-intercepts, and up here and y-intercepts. It's going there. Okay, so there's the graph, and we're gonna get the actual graph from the calc. But you got to be able to find the points and the intercepts and the asymptotes. All right, let's go one more. This one says graph this one and take the domain and range. Okay, so as usual, we need to factor everything first. So the numerator does not factor. It's just 5x plus 21. No big deal there. The denominator would be x plus 5, or just x plus 5 squared. Either way you want to do that. So the x-intercept, where we find x-intercept, remember, is whatever makes the numerator 0. In this case, it's -21/5. And if you can't figure that out just by looking at it, you can take that to the side somewhere, set it equal to 0, and solve it. The y-intercept, I'm going to plug a 0 in everywhere, there, and there. That leaves me a 21 and a 25. So there's my y-intercept, which is a weird number 2. The vertical asymptotes, whatever makes your denominator 0, which would be -5. So don't forget your x equals -5. Your horizontal asymptote, I'm looking for the degrees. The degree on the top is 1. The degree on the bottom is 2. Because the degree on the bottom is bigger, that means the horizontal asymptote is y equals 0. Okay, so we use all that info. I'm going to try to blow this graph up right here as best I can. And let's plot the stuff that we have. I know the x-intercept is -2 negative 21 fifths. So it's like that's negative 4 1/5. It's way out here. That's not very accurate. The Y-intercept is 21 25ths, which is almost positive 1. So right there. The vertical asymptote is x equals negative 5, which is about here. Pretty close to that point. It's the only one. The horizontal asymptote is actually the x-axis. You don't have to darken that if you don't want to, but you can, obviously. So punching it in the calculator, see what the graph's going to look like, and sure enough, found it, and it looks very much like, basically you're trying to figure out what's going on around the asymptotes. Right here it's doing this. On the other side of this asymptote, it's going up here, and then all of a sudden it makes a sharp turn and it comes back down because it's got to go closer and closer to the asymptote at the end. Remember, the horizontal asymptote tells you what it's doing at the ends of the graph. The left end's getting closer and closer to it, and the right end's getting closer and closer to it. That's a big deal. The horizontal asymptote tells you what's happening at the ends of your graph. Okay, last word here for rational functions are slant asymptotes, or they're also called oblique asymptotes. So far we've done a vertical asymptote and horizontal. Sometimes they're slanted, and here's when. When the degree of the numerator is one more than the degree of the denominator, that's when you have a slant asymptote. And the way you find it is just by dividing. And it sounds worse than it is. It's really not that big a deal. But you're going to have some unusual looking graphs when you do your slant asymptotes. Let me show you one more and we'll be done. Okay. It says graph this rational function. So same stuff. I'm going to start out the same way. The steps are the same. I'm still going to factor. So the numerator is going to be x minus 5, x plus 1. Denominator is x minus 3. Okay, so my x-intercepts, whatever makes the numerator 0. So my x-intercepts are going to be 5 and negative 1. The y-intercepts, you just plug in zeros everywhere, and that gives you 5/3. The vertical asymptote, whatever makes the bottom 0, which is 3. Now here's the deal. There's not going to be a horizontal asymptote. Because of our rules, remember, anytime the top degree is larger than the bottom degree, there is no horizontal, so there's no horizontal asymptote. And there can't be a horizontal asymptote if there's a slant asymptote. Okay, so I got to find a slant asymptote. And again, the way you do that is you divide. So I'm going to take that x squared. I'm not going to put x squared there. Put a 1 there. Put a 1, a negative 4. I'm just dividing here using synthetic. 3 goes in the box. Bring the 1 down. 1 times 3 is 3. That's negative 1. Now, the remainder here is really meaningless. You do not need to worry about the remainder. If you did do the remainder, obviously you're going to get negative 8, but that's not going to be your slant asymptote is y equals your quotient. And your quotient here is x minus 1, okay, from right there. That's your slant asymptote, that line, y equals x minus 1. That's what I'm going to draw, okay? Let me get a picture of a graph real quick, and we'll graph this thing up. Voila, magically there's a graph down there. So let's make it a little bigger here. Let's see what we can do. First of all, let's start with the intercepts. The x-intercept is at 5. And also at negative 1. The y-intercept is at 5/3, which is almost 2. There's those. The vertical asymptote is at 3. So I'm going to draw that here. There's the vertical asymptote. I'm trying. There we go. I'm not really hitting that line very well. There's the vertical asymptote. Slant asymptote, y equals x minus 1. Guys, that's slope intercept form. Crosses y-axis is negative 1. Slope is 1. Connect the dots. La, la, la. There's your slant asymptote. Doing that right there. So what you need to find now is what's happening around your asymptotes. So you can draw the graph. So we're just going to punch it in the calculator real quick, see what's going on here. And what I'm seeing over here is this. It's starting up here, getting closer to the vertical, starts coming down and goes through those 2 points, and sure enough, it's getting closer and closer to that slant asymptote as it goes. On the other side, the same thing's happening. It starts down here. It's coming up, getting closer and closer to that asymptote as it goes up. I kind of missed that point there. So just make that point a little bigger. Same thing there. All right, guys, and that's it. Okay, calculator. Make sure you have your calculator with you tomorrow. Come in very handy. Make sure you know how to find the x-intercept, y-intercept, vertical, horizontal asymptotes, and the slant or oblique asymptote. All right, see you in class. We'll work on them like we always do. See you then.